Saxon Algebra 1/2, lesson 36. Remember how we've been playing around with these rates? We had a little bit at the end of a lesson where we talked about, if it's this many toys for this many dollars, we can build a rate out of it. Well, we're gonna go back to that and expand on it again. Remember that a rate is a ratio, and a ratio is a fraction. All of these things are similar, and so when you hear rate, don't freak out. It's just a special kind of fraction. Remember too that another example of a rate that's a ratio, that's a fraction, are our unit multipliers. And these problems are very much like our unit multiplier problems where we're converting things from one to the other. That's really what we're doing. And there's a simple little formula that we use. This is the way John writes it. Our rate times a number equals a total. Well, I'm not going to argue with him, but that's not the way I think of these. I think of rate times what we know equals what we don't know. Okay? Let's try a few and then you can see if you like one of those formulas better than the other. Reminder, you know how with our unit multipliers, we can take the same information and write the ratio in two ways and then figure out which one we want to use? That's exactly how these problems work. Let's try. Example 36.1. There are only two. 20 apples cost $5. How many apples can we buy for $80? Okay, so the first information we're given is information about the rate. So I'm going to draw a box for that. I'm going to make it a little bigger because we want to write a word in there. It's not just like inches or feet. We want to write a whole word. That comes first in these problems. Then we're going to multiply that by what we know, and then that's going to equal what we don't know. 20 apples cost $5. That's our rate information. We can write it two ways. 20 apples for $5. Notice I write it out instead of a dollar sign. It just helps. Or $5 will buy us 20 apples. Now, those are our two choices. But before I get too excited about them, I notice that these numbers could be reduced, couldn't they? In our unit multipliers that we use for our conversions of length or area, you can't reduce how many inches are in a foot or anything like that. So these are a little different, but we can reduce this to 4/1. 4 apples for $1, or $1 gets you 4 apples. Now, we still don't, so we've got two lovely rates here that are reduced, but we don't know which one we want to use. First, we want to look at this number, what we know. It goes on to say, how many apples can we buy? That's what we don't know, for $80. So I do know that we have, no, not 88. No, it's 80. We have a lot of dollars to spend on apples, apparently. Okay, so this is what we do know. We have $80. And what we don't know is how many apples we can buy. All right, so I fill in the other information and then I ask myself, which of these two rates is going to give me the answer I want? Well, just like with unit multipliers, we look at the unit next to it and we want to cancel this, right? So we want dollars on the bottom. And that is this version. So we want dollars on the bottom and apples on the top, because look what will happen. The dollars will cancel and we'll be left with apples, just like we do it with the unit multiplier problems. And that's why in these problems we always make the word part of the problem, just like in these, because they help us pay attention to where the numbers are going. And if we can get our words to behave the way we want, then the numbers will follow along. So now our units have behaved just the way we want, and we're ready to multiply our numbers. It's usually fairly easy to do the multiplication. This tells us we will get 320 apples. Now, there's no doubt in my mind that you could have figured out, well, if 4 apples cost $1 and I have $80, it's 320. You don't need this whole process to do it. Trust me, it's gonna get harder. Ask Jayla and Laura and Vivian if the rate problems don't get just a little bit harder over the years, and they'll tell you, oh my gosh, just do it this way and it's so much easier. All right. 20 apples cost $5. Oh, it's the same rate. The second problem has the very same rates as the first one. 20 apples cost $5. So there it was, 20 apples, $5, $5, 20 apples. Then we reduced the numbers. We can use these very same rates. This time, it says, what is the cost of 40 apples? So what we know is that we want 40 apples. And what we don't know is how many dollars it will be. All right? That's why I like this format rather than John's way, is because it helps. This is what the problem tells us. This is what we're trying to find out, okay? So this time we know, instead of knowing how much money we have to spend, we know how many apples we want in the end, and we're trying to figure out our price. So this time, we use the same logic again as we do for multipliers. We want, if apples are up here, then that means we want apples on the bottom. And that means dollars are up here. And this time it's the other rate, isn't it? So it's $1 for every 4 apples. So let's make sure our units behave. Apples cancel, dollars are left. Yes, that's what we want. And so now we can do the math. It will be 40 over 4, or $10 is what we will need to buy those 40 apples that we want. And that's also the right answer. Again, I know you could do this in your head, but trust me, it'll get harder. So just learn the process. But that's all there is to it, you guys. That's 36. The practice problems, I want you to do all 3 of them this time. Write 2 rates or ratios or fractions implied by this statement. Chestnuts cost 40 cents for 2 ounces. So 40 cents over 2 ounces, 2 ounces over 40 cents, reduce the numbers. And then how many ounces of chestnuts can you buy for that much money? And what would be the cost of that many chestnuts? Do all 3 parts, please. And if you're not sure if you got the right answer for B, message me and I'll help you. Okay, that's the end of 36. So long, farewell, auf Wiedersehen, goodbye, goodbye.